Welcome to the Explainer. Today we're diving into something that is literally rewiring how front offices, coaches, and analysts view the game of basketball. We're talking about how optical tracking data is finally letting us put a precise value on every single micro decision happening on the court in real time. If you've ever watched a game and just known a player was dominating, even if it wasn't showing up in the stat sheet, well, you're absolutely gonna love this. So let's jump right in. There's this brilliant quote from the Harvard researchers who originally presented this data at the MIT Sloan Sports Analytics Conference. They pointed out that basketball is essentially a high-speed chess match. But think about how we traditionally evaluate that match. We really only look at the very last move, right? The one that results in checkmate. We see who scored, who got the assist, who turned it over, and we completely miss the genius of all the setup. And that right there is the core problem. It's the box score's massive blind spot. Even advanced metrics like player efficiency rating rely super heavily on what researchers call terminal states. Basically, how did the play end? Did the ball go in? Was there a rebound, a turnover? But focusing just on that completely ignores the tactical substructure of the game. It totally misses the subtle drives, the floor spacing, and that complex sequence of passes that actually created the opening for the shot in the first place. Section 1. The basketball stock ticker. Introducing expected possession value. To fix this huge gap in analytics, researchers basically proposed a completely new microeconomics for the NBA. They needed a way to measure the value of a possession at literally any tenth of a second, not just at the final buzzer. So enter expected possession value, or EPV. EPV assigns a concrete point value to every single tactical option a player has in real time. It calculates the expected number of points the offense will score based purely on the exact spatial configuration of all 10 players and the ball at that exact millisecond. It's asking the math, based on where everyone is standing right now, how many points is this possession actually worth? Now, to actually calculate this, the model takes every single possession and chops it up into two categories. First, you've got microtransitions. These are those instantaneous, continuous actions, like a player shifting a few feet left or right with the ball. Second, you have macro transitions. These are the discrete, multi-second actions, like a pass, a shot, or a turnover. The model is constantly evaluating the probability of what the ball handler is going to do next, based on these subtle little movements. It's kind of like tracking a stock's volatility right down to the millisecond. Section 2. Anatomy of a game winner. The Spurs versus Cavaliers, February 13th, 2013. Let's actually put this on the court and see how it builds. We're looking at a real-world example where the Spurs were down by 2 points with less than 10 seconds left on the clock. The play starts with a baseline value. The Spurs inbound to Tony Parker, and Tim Duncan comes up to set a screen. At this precise moment, the expected points for this possession sit at 0.86, so the stock is floating right around a single point. But then, Parker uses that screen and drives hard right into the restricted area. He draws the entire defense into the paint, and look what happens to the math. The possession stock price dramatically spikes to 1.36. Parker just made a massive tactical contribution by collapsing the defense, which is an action that traditional box scores completely ignore, simply because it's not a shot or an immediate assist. Now, deep in the paint, Parker could definitely try to force a contested layup to tie the game. But instead, he makes the incredibly smart choice to dish it out to Kawhi Leonard, who's standing wide open in the corner. Because of that pass, the expected points bump up once again to 1.46. So think about it. Parker has grown the value of this possession twice, all without taking a single shot. And this brings us to the absolute peak of the possession. Leonard catches the ball, takes the open three-pointer, and pushes the EPV to its absolute max at 1.58. He sinks the game winner, and there's your checkmate. But notice how this system works. Parker gets mathematical credit for his drive and his setup, regardless of whether Leonard's shot actually goes in. The value was created by the decision, totally independent of the final result. Section 3, rating the decision makers. Expected possession value added, or EPVA. Once we have this stock ticker running for every second of every game, we can start doing some really powerful stuff. We can evaluate players based on the decisions they make compared to what a league average player would do in that exact same spatial situation. And the crucial takeaway here is how the elite players separate themselves. Back in the 2012-2013 season, Chris Paul led the entire league with an EPVA of positive 3.48 points per game. That means, purely through superior decision-making, utilizing space, and setting up teammates, Paul was generating nearly 3.5 more expected points per game than an average player would have.
But of course, the math exposes inefficiencies too. We can sharply contrast the league's elite decision-maker, Chris Paul, with Ricky Rubio, who, during that same season, sat at the absolute bottom of the league for this metric at negative 3.33 EPVA.
Now, let's be super clear here. Rubio's negative score doesn't mean he's a terrible basketball player. Actually, it means he faces a very specific dilemma. When Rubio gets the ball in high-value areas, like unguarded in the restricted area, the league average expectation is extremely high, right around 1.57 points. Why? Because most players just take the easy layup. But Rubio has this tendency to pass out of those situations to teammates on the perimeter. So his decisions in those specific high-value moments result in fewer expected points than the league average. And that's what drags his EPVA down.
Section 4, a new basketball microeconomics, beyond the final shot.
Okay, let's zoom back out. Why does all of this fundamentally change sports analytics? Well, this framework lays the foundation for a whole new level of sports intelligence. Front offices can use EPV to objectively measure trade values by simulating what happens if you swap a player's decision-making profile into a brand new offense. Analysts can spot what they call selfish assisters, the guys who hold the ball way too long, just looking for a stat-padding pass rather than making the right macro transition. And coaches, they can mathematically design optimal defenses built specifically to systematically force opponents out of these high EPV zones. So we are officially moving from a world that only counts the final points to a world that finally values the sheer intelligence of the build-up. The next time you sit down to watch a game, ask yourself, are you just going to follow the bouncing ball and wait for the checkmate? Or are you going to watch the hidden stock ticker on the court and see the true value of the moves that set it all up? Thanks for joining me on this explainer, and I'll catch you on the next one.